this video, I'm going to demonstrate some of the integrations that we've been building between Omnisci databases and Jupyter Lab. Jupyter Lab is a web application that provides a interactive programming environment for Jupyter notebooks and other activities in the Jupyter-related ecosystem. So what we see here is a launcher that allows us to launch any of a number of different activities. There's a fairly straightforward menu bar. On the left side here, we have a file browser. We also have a list of running sessions, a command palette, and a list of open tabs. So from this, I can, for instance, open up from the file browser, I can, for instance, open up a markdown preview of the README. I can also open a new terminal that will allow me to keep track of my system resource usage. And I can also, for instance, open a new notebook. And so we can drag and drop and lay things out in any way that pleases us or fits our work style, and have this very nicely integrated environment for interactive programming. Jupyter Lab is designed from the ground up to be extremely extensible. So to that end, third parties can write extensions that add new things to the menus, add new things to the command palette, add new types of activities and data types that the application can render, and really sort of do whatever you like. So to that end, we've been adding certain functionality to Jupyter Lab that allows us to work with Omnisci databases more fluently and more easily. So to begin with, I'm going to close these things out and show in the menu here, we've got an item to set the default Omnisci connection. This stores a set of connection data that will auto-populate in the various activities that we're going to be showing you today. So to begin with, I'm going to launch a SQL editor. So here we've got a nice blank slate. At the top, we've got a text field where I can start composing a SQL query. So we can, for instance, compose a query using the FEC contributions example data set. So we've got the computer wired up so we can get smart completions. And maybe we get the city, state, and amount of the contribution from this table, and maybe we want to filter it where the amount is greater than $10,000. Execute that, and the results come up in this high-performance data grid, so we can scroll up and down really easily, and it can stand up to quite large data sets being returned from the database. So this SQL editor is nice, but we also want to be able to interact with the Omnisci database in Python to do more general purpose programming tasks. So in order to do that, I'm going to start a new Jupyter notebook. And so the main interface that we've been developing for people to interact with the Omnisci backend, the Omnisci database, is IBIS. IBIS provides a library that allows you to write more Pythonic code for executing queries on SQL-like backends. So I'm going to activate a convenience function in the command palette here, which injects the appropriate code for connecting IBIS to the Omnisci backend. So I'm going to activate that, and we get this code injected into the notebook. And when I execute it, I do get the list of tables from our example database. So to start, let's select one of the tables from this database. I'm going to select perhaps the tweets database from the tweets table from the database. and we're going to select some columns from that table by composing an expression. By selecting this, and maybe the followers for even Twitter user. So this expression, if I output it in a cell, is not immediately evaluated, but it in fact gives us a nice visual representation of the query that's built. I can also output the SQL query that will be executed by the backend by writing expression.compile, and see we get a fairly straightforward looking SQL query. And then in order to finally execute this, we can say expression dot, and we get our data back as a pandas data frame. So this is all well and good, but sometimes it's nice to be able to have an escape hatch to explore with raw SQL. And so to that end, we've also made it possible to embed our SQL editor in a notebook environment. So I'm going to import a Python library that we've written for this purpose. And from that, we're going to use the SQL editor renderer and give it the connection and our expression. And so what this does is it actually embeds that same SQL editor that we saw before inside the notebook with that expression preceded in our field here, in our text field here. And this is a live SQL editor, so I can also add any followees to this table in addition to followers and re-execute the query, and now I have this new column in the SQL editor. And so we think that this will provide a nice, more Pythonic and interactive way for people to integrate with the Omnisci databases from their notebooks and from Python code. Finally, I wanted to show an example using the backend rendered Vega that the Omnisci database provides. So here is a Vega spec. This is drawn from one of the Vega examples given in the Omnisci documentation. I can open this spec with a text editor, and you can see that it is in fact JSON, a JSON Vega specification. But we've also made a custom renderer for this JSON spec that connects to the Omnisci backend and actually executes that Vega and gives us back the image that will result from it. So here is this same Vega spec open with this new viewer and shows the image that results from executing this Vega. And so to prove that this is in fact a live data model, so these two tabs are in fact two views on the same thing, I can change this fill color to red instead of the heat map that we saw earlier. Change it to red and re-execute it, and now we get back the image in red. So we think this set of tools that we've made will be useful for people to more easily interact with the Omnisci ecosystem and allow Python users to more easily do lightning fast analytics.